Keras and TensorFlow, these are two packages that are most important for you in further study, and I will just introduce to this and you can then practice on your own further. And this is a must for all AI students. Okay, so you must know these two packages thoroughly. Now, what is TensorFlow? TensorFlow is an end-to-end open source platform for machine learning. And TensorFlow makes it easy to create machine learning models. This was proposed by Google Brain team of Google, and the name TensorFlow is derived from the operations such as neural networks perform on multidimensional data arrays, and that is referred as tensor. So TensorFlow 2 focuses on simplicity and ease of use with updates like eager execution, intuitive higher level API, and flexible model building on any platform. So there was earlier TensorFlow 1, which was a little bit difficult to write and run. So now they have removed all those drawbacks. So you just search for TensorFlow 2. Uh, when you install it, don't install 1.0. By default, it will install now 2.0, but by chance you see some problem, then you must check whether your version is 2.0 or not. Now, TensorFlow is tested and supported on 64-bit systems. It requires 3.5 to 3.7 or 3.5 and higher version of Python. So this is running on Windows as well as Linux-based systems. So this is quite flexible. You can call in all these platforms, including Mac OS. So what we have to do, we have to download it freely, install TensorFlow with Python pip package. So you can just give this command, pip install TensorFlow, so it will install it. So basically TensorFlow is for handling matrix operation, say vector multiplication, matrix multiplication, handling this such big data. It's very easy to use tensors. Okay, so TensorFlow is meant for handling, you can say, matrices. Now Keras is the second package which uses TensorFlow. So Keras is a high-level neural network API. So this is a high-level neural network API written in Python and capable of running on top of TensorFlow and Theano and so on. So basically we will be using the combination of Keras and TensorFlow. Now what has happened, Google has even included Keras in their TensorFlow. So now these two, TensorFlow and Keras, they will be installed in one go. You need not worry about their double installation also. You can, once you install the package, it will be installing both these things. So I will show you how to install it. It was developed with focus on enabling speedy implementation of ideas. So why Keras is powerful? Because it has a very good amount of ready-made commands to implement neural networks. Okay. So your focus will be on development of new architectures, and though that focus you can easily achieve with the help of Keras. So you did not worry about how to handle data, how to pass data, that all the things will be taken care by Keras. What you have to do is you have to just add proper commands one after the other so that an architecture is created and that we can use directly. So I will show you one example how to do that. Supports this Keras supports both CNNs and recurrent networks. So this recurrent part we could not cover. So recurrent is you take input and then it is fed back. Okay. So recurrent is that kind of system, and basically it is used in deep structures to generate to have this language processing. Okay. So suppose I give you image and I ask you to describe it. Say write one page on this some image. So if I ask a computer to do this, that I will supply you some image and you have to generate accordingly text for that. So now it is possible with the help of RNNs, and the advanced versions of them is LSTMs or transformers. So all these are some upgradation to basic recurrent networks, and that we use to generate such kind of text for the images. Now this runs seamlessly on CPUs and GPUs. So GPUs, if you have, that is supporting the this tensor processing. So remember, so I have a GPU in my system, along with, actually I should have a CPU at least, and then I should have association of GPU. So this combinedly will form a system nowadays. And if it is a NVIDIA based GPU, it is supporting all these neural network activities. Okay, so GPU developed by NVIDIA company is doing all this neural processing job. Even in our lab, we have NVIDIA platform. Okay, so this CPU plus GPU combination will give you very fast implementation of neural networks. Okay, so what GPU will do, it will do this processing of tensors. So it has inbuilt structure and algorithms which will process these tensors, that is matrices and vectors, very fast. Okay. To do this same job by CPU, that normal our CPU maybe of Intel or so, it is difficult, or it will be time consuming to do this things along with your regular job. That is, when a PC is running, so many things are running. So along with this, if you ask that PC to do all this neural network training, so it will take some more amount of time. But when you have a dedicated GPU which is doing this job of tensor processing, then this CPU gets a lot of time to do other things. So the headache is removed. So your implementation will be faster. So by default, Keras will use TensorFlow as its tensor manipulation library. Now, the Keras is popular because of user friendliness, modularity, easy extensibility, and it's basically using Python. So I hope now by this time you are familiar with Python. So I think you are writing programs in Python, so you can easily try for this. So I hope you are using Anaconda as your platform. Are you using Anaconda?
Yes, sir.
Okay, so I hope you know this step, how to download it from net. So suppose you have downloaded from net, it will look like this, and then you create a new environment in your Anaconda. Maybe you can give your own name. So you can create environment with your own name, because we need to modify some packages, or we require some extra packages, and that you will require for each your running instance. So you can create your own required environment without disturbing the main environment. Okay, so once this is done, install your TensorFlow using pip command. Then we will see one example. If suppose everything is done successfully, then we will see the very popular data set called as MNIST data set, and we will try to create one network to train this. So MNIST is Modified National Institute of Standards and Technology Database. In short, it is called as MNIST, which is very popular for deep learning. So it consists of such type of handwritten numbers 0 to 9, and they are now supplied along with these packages so that you can write hello kind of a program using this. So this will be your image. Then you have many layers here of CNNs, and then you flat the image, and then you produce some output. Now we will take this example of VNet that we have seen yesterday using Keras. So as I said, this network was proposed in 1998 by Yang Lee Kun and Yasho Benju. So there are others also, but these are very popular figures in deep learning. The first line is just importing your TensorFlow. You have to just write TensorFlow as TF, and then you say import Keras. Okay, so these two lines, 2-3 lines are compulsory, and you just write them. And then, as I said, this Keras is Keras has inbuilt this data set MNIST. So you just say load it, so it will give you say 2 sets. One is train set, other is a test set. So just divide by 255 to normalize it, and then you have the corresponding commands to make this thing ready for training. Okay. Now here I am showing you this architecture that we have seen yesterday, and there are some corresponding commands for that. Now the first thing is you give some name. Since this is a linet, I am just saying linet 5 model. So equal to keras.models.sequential. Okay. So once you do this, you start creating different layers. So these are different layers created in this architecture. So these few lines up to this will directly create these layers that you are seeing. So we can just relate it one by one. The first line is Keras convolution 2D. So there are 6 filters. You can count here 1, 2, 3, 4, 5, 6. So 6 filters of size 5 by 5. So these filters convolution size. So this convolution size is 5 by 5, and actually these are outputs. So this 5 by 5, there are say 6 types, and when I take the image and convolve this 5 by 5, the first output will come. Then I take the second 5 by 5 filter and roll over this, it will give me the second output. Then I take third one, and so that I will take 6 such 5 by 5 convolution mask, and I will create 6 feature maps. So this is done with the help of just one single line command. Okay, so activation function for this particular thing is tanh, and then I have a second line which is the average pooling line of this layer, Just we have to write this command, so it will do everything inside. So it's very simple to implement and just calling those things. So when I just write here average pooling, all these 6 outputs of previous layer, they are downsampled using average pooling, and you will get 6 such outputs of size 14 by 40. So initially it was 28 by 28. Now I said I will downsample it by 2, so it will create 14 by 14. Okay. The next command you see is convolution 2D of size 16. So here we have now 16 filters. Earlier there were 6 filters. Now here we are creating 16 filters. 16 filters of size 5 by 5. Again 5 by 5. So size is here 5 by 5. Stride is 1, that means you will be shifting 1 pixel by 1 pixel. So you will not jump. Okay. And activation function is tannage, and padding is valid, so you will pad automatically those zeros. So this is done with this command automatically. You have to just write it properly. So you will get on Keras website all the details and the other options for this. But this is sufficient. You can copy this and you can straightway run this program. So 16 layers we created here. And 5 filters, 5 by 5 filters. Again we have here subsampling, and then we say flatten. So flatten means all these small outputs, they will be arranged one after the other and one big vector is created. So that is called as flattening. And then we have these dense layers. As I said, there are only 3 layers. So these dense layers are written with 120 units, 84, and then 10. 10 is last layer, that is number of classes. Okay, so then you just run it. You just say compile this model, use fit command, and evaluate. So you will get your result. Okay, then the model is ready. So like this it will run, and then you will get loss, how much you will lose. Okay. So I think this is enough. So we will study it in detail.